In Vue Mastery's Real World Vue 3 course, we're going to build a production level app using Vue 3.
We'll start off by creating our project with Create Vue.
Then we'll learn about single file Vue components and how they can be used to create a single page application. We'll cover the fundamentals of Vue Router so we can navigate between the different views of our app. And our app will even fetch real external data using API calls with Axios. Finally, we'll end by learning about the build process and how to deploy the app into production. So if you're ready to learn how to build a Real World Vue 3 app, I'll see you in the rest of the course.
In this lesson, we're going to get started with our Real World 3 app. We'll start off with creating our project with Create Vue. This is a CLI tool based on a build tool called Vite.js. Then, once our project is created, we will tour that project to understand how it is constructed. Create Vue is a command line tool to help out with creating a Vue project. As you probably know, CLI stands for Command Line Interface. So the Create Vue CLI provides a full system for rapid Vue.js development.
It does a lot of tedious work for us and provides features out of the box. It allows us to select the libraries our project will be using and automatically plugs them into the project.
Create Vue is powered by Vite. This means that all of our JavaScript files, our CSS, and our dependencies get delivered in a lightning-fast build for development.
It also allows us to write our HTML, CSS, and JavaScript however we like. It gives us the freedom to use single-file.vue components, TypeScript, SCSS, Pug, the latest versions of ECMAScript, and more. The CLI also enables HMR, or Hot Module Replacement, so your app updates live whenever you save a change.
We can create a new Vue project using npx create Vue.
And then the name of the project that you're creating, in our case, Real World Vue. This will start guiding us through a process where we select the options to configure our project.
We're going to choose No for TypeScript and JSX. And for Vue Router, we'll choose Yes. And for Pinia, we'll choose Yes as well. Then we'll say No to unit testing and Cypress. Lastly, we'll say Yes to ESLint and Prettier. Once our project is scaffolded, we can cd into that project and run npm install to get all of the dependencies. Then we'll go ahead and start the development server with npm run dev. This will compile our app, and as you can see, it's running on localhost 5173. Your number here might vary depending on if you already have a localhost running.
Now if we head to that localhost in the browser, we can see the app that was just created. You can see that some basic routing is already set up for us, where we can navigate between the home and about views. Now that we've explored different ways to create and manage our projects, let's open up the project and see what was created for us. Starting at the top here, we have this node modules directory. This includes the dependencies needed to build our project. Then we've got the public directory, which you could use for files that you don't want processed
through Vite.js.
Then we've got the src directory. This includes all of our application code, such as our assets where we might store things like images, style sheets, etc. And a folder for our components, which are the building blocks of the app. We've also got a folder for Vue Router, which is used for app navigation.
And then a folder for our Pinia stores, used for state management. I should note here that by the end of the course, you're going to have an understanding of what Pinia is for, but we're not going to cover it in depth in this course. We have an entire Pinia playlist of courses for you to check out after this course.
The views directory stores the components for our different views or pages of the app. And app.vue is the root component of our app. All other components are nested within this. And finally, main.js renders our app and mounts it to the DOM.
Additionally, we have an ESLint config file, a git ignore file to tell Git what to ignore from our project, a Prettier config file, our index.html, along with the package.json files, a README, and the Vite config file.
Now, before we wrap up this lesson, let's understand what's happening in main.js. At the top here, we're importing create app, which is a method from Vue, and we're also importing app.vue. Remember, this is the root component in which all other components are nested. So all of our application code is in this component.
So here we're creating our app and telling it to use Pinya and router.
And then we're mounting it. So where are we mounting it exactly? In the argument, we're specifying where we want the app to be mounted. Notice how we've passed in the ID of app. Notice how we have this index.html file. And at the bottom here, we've got this div with the ID of app. In other words, when our project is built, this is where our application code is going to go. Let's look at this process visually. Remember how we've got our app.vue file. This is our root component in which all of our application code is nested. And our main.js takes all of that application code and creates our app, mounting it to the DOM, specifically where that div with the ID of app lives within our index.html. And with that, we now have a basic understanding of how our project is working, and we're ready to start customizing it. In the next lesson, we'll build our first component. See you there. Now that we've created our project, we're ready to start customizing it and building our app. So in this lesson, we're going to take care of a bit of housekeeping. We're going to look at the app we're going to be building throughout this course, and then we're going to start building it using single file components. As we build the app throughout the rest of this course, I'm going to be referencing some concepts and syntax that I covered in the Intro to Vue 3 course. So if there's anything that seems a bit unfamiliar to you, you might want to check that out. While taking this course, I encourage you to code along so that you can learn by doing. To help with that, we had the starting and ending code in the GitHub repo for this course. To access the starting code, you'd head into the terminal and locate the project, then run git checkout L3-start. L3 refers to the lesson that we're on, lesson 3. When you open up that starting code, you'll see the project like so, and I want to bring your attention to this prettier RC file that I've created. As you can see, I've set up some rules so that prettier will change any double quotes to single quotes, and semicolons will be removed. This is a basic example of how you could set up some prettier configurations for your project. I'm not advocating for or against semicolons or single quotes. You can set this up however you like, or just ignore the file altogether. In order to start customizing this project and building our app, we've got to get a little bit more familiar with how it's working. If we take a look in this views directory, we see these two .vue files, home and about. If we check out the project running live in the browser, we'll see home and about right here. These are the two views that Vue Router is using for our site navigation. In the next lesson, we're going to cover Vue Router essentials, but for now, you just need to understand this. These files in our views directory, home and about, are what is loaded up and displayed by Vue Router, and whatever is nested within them is also displayed.
For example, the home view file has the welcome file nested within it,
which contains all of this code that we're seeing. All of these components have the .vue extension, meaning they are single file Vue components. So that's what we're exploring in this lesson. What is a single file Vue component? How is it composed? And how do you use them? But just before we get into that, I want you to take a note of this H1 here. You'll see why in just a minute. When looking at an app built in Vue, we're really looking at a collection of Vue components, traditionally built with single file Vue components. The anatomy of a single file component looks like this, with a template, script, and style section. You can think of the template as the skeleton of the component because it gives it its structure. And the script is the brain, giving it its functionality and behavior. And the style section, well, it gives it its style. You can think of it like the clothes, makeup, hairstyle, etc. Often these sections are written in HTML, JavaScript, and CSS respectively, but you also have the freedom to use alternatives such as TypeScript, SCSS, etc. So now that we're starting to understand what single file components are and how they're built, let's move back to our application code.
Remember, just a bit earlier, I brought your attention to that "you did it" text. As we can see in the app.vue file, there's this hello world component imported here and nested within it. And there we can see the message "you did it" fed in as a prop.
If we take a look inside the hello world component, we'll see that this h1 is displaying that message prop. So now we're seeing how a parent component can pass its child component some data that it can then display in its template.
We can see here the script code and the template code, and if we scroll down, we can see the style section. Notice how the style tag has a scoped attribute.
Taking a look at this concept deeper, the scoped attribute allows us to specify and isolate styles to our given component. In this example here, we're telling the component that any of its p tags are going to have a font size of 16 pixels. However, that style is not going to affect any other components in our application because it's scoped just to the component that we care about. Great, so we've covered what a single file component is and how the project was using them. Now we can start deleting out all that demo code to build our own app. What does that app look like? Let's take a look. By the end of this course, this is what we're going to build. It's a simple app that helps out the world one event at a time. As you can see, we're displaying a list of events, which we're pulling in through an API call. And when we click on an event, we can see the event details. Additionally, we can route to the About page. By now, you're probably ready to start building the app, so let's head back into the code and start building our first components. We'll use the Hello World file as a starting point.
First, we'll comment out the props. Then we can delete out all of this template code in the div. And then we'll just get rid of all these styles.
Now we can rename the component here to Event Card. Why Event Card? Because this is going to be the little card that is displaying those events.
Now, since the Hello World component does not exist anymore, we need to go into the app.vue file and remove this import line. Then we'll remove the Hello World component from the template. While we're here, let's also set up the layout for the app. First, remove the Vue.js logo, and then we'll wrap everything in a layout div. Let's also add a separator in the navigation menu. Now I'm going to replace all of this CSS here with some new CSS for the layout. Now we just need to go into the main.js file and remove this import here on line 7. While we're at it, let's also remove all the files that we no longer need, including these welcome components and the icons folder. Finally, we need to go into the home view and remove the welcome component here. Then we'll replace the template with a div. Now, if you head into the browser, the layout should look like this. And soon, the page content will show up here.
Now that we've cleared out that code, we're ready to start adding some structure, brains, and style. We'll start off by changing this class name to Event Card and add some styles for the event card, including a hover effect. Inside the div here is where we'll display the event data, which means we're going to have to add event data to the component,
which we'll do in the script section by importing ref, and we'll use that to create a state. That state will be a const called event, and we'll paste an object here. As you can see, it's got a bunch of properties here, such as an ID, title, location, date, etc. Now we can head down to the template where we'll add an h2 to start printing out information from this object. We'll do so with an expression that displays the event's title, using dot notation with event.title.
And add a span that shows when the event is happening. So we'll type the @ sign, then use an expression which says event, referring to the event in our data, .time, then we'll say on, and use another expression to print out event.date. In order for this event card to be displayed, we have to put it somewhere that can be routed to, such as the home file in our views directory. So inside of here, We'll import event card from the components directory.
Alternatively, we can use the @ sign to make this an absolute path. And now we can use that newly imported component in the template.
Checking this out in the browser, when we're on the home route, we can see that it's working. Our event card is being displayed. We're definitely making great progress, but remember, we want these event cards to be showing up here in the middle, and we're going to want to be displaying multiple events eventually that we pull in from an API. So in order to get prepared for that, we need to do a little bit of refactoring.
Our refactoring to-do list includes the following items. First, we'll want to move the events data to the parent, homeview.view.
The reason for this is because, as I mentioned, we're going to have a whole collection of events. So we want the parent to have that collection and to be creating a new event card for each event. Which leads us to the second to-do item, where we'll set up the parent to create our event card components based on that event data that it has, feeding each of those event cards its own event through a prop. And then finally, to make things look good, we're going to wrap all those event cards in a Flexbox container. To refactor our event card, I'm going to uncomment the prop here and set up an event prop, which will be an object. Remember, the parent is going to feed each event card its own event to display. Now we can delete out this event data. And that's it. Event card is ready.
Now we'll head into the parent component, HomeView, and we're going to give this component some data that it can use to create the event cards. So we'll import ref here at the top, and then use that to create a reactive ref here called events, which will be an array of event objects.
Because we want to create an event card for each of these events, we'll v4 through the events. Each of these event cards is going to need its own key so that Vue can keep track of these. So we'll bind the key attribute to our event ID. And then finally, we'll add an event prop and pass in the event object that we're currently iterating over. So to review, each event card receives that event prop, and then it can display those event details.
Since we no longer have the event ref inside of this event card, we can go ahead and delete this import statement.
If we check this out in the browser, now we see 3 event cards, so it's definitely working. Now we just need to display this all correctly and wrap these event cards in a Flexbox container.
So heading back into the homeview.view, we're going to change the class name on this div to events.
And head down here and add a scoped style section. And I'll paste in these styles, where we're creating a Flex container that is a center-aligned column. At this point, we've covered how to add styles that are scoped to the component itself, but what if we wanted to add a global style that were applied to the entire app? Where would we put that? A simple way to achieve this is to head into the app.view component, which is the parent component of our entire application.
If we remove this scoped attribute from the style here, that would make all of these styles global styles, meaning they would be applied to our entire app. So we could add another rule here. For example, if we want every H2 in our app to be a font size of 20 pixels, we could add that here. And since our event card has an H2 inside of its template, this global style will be applied to that element, along with being applied to any other H2 throughout our application.
While we're on the subject here of adding things globally to our application, if we scroll up, let's add an H1 here and see what happens.
Looking at the app live in the browser, we can see that H1 along with these H2s, which are now much smaller.
And when we navigate to the About route, we're still seeing that Events for Good heading.
We can also see that the page content is positioned down here. We're going to fix this later.
So if you needed to implement something like this where a heading or something else showed up no matter where you were within the app, it could go within the app.view file, like so. But for our use case, we don't necessarily need this to show up everywhere, so let's move that. We'll just cut it out of app.view and put it in the template of home.view.
Now let's fix the positioning of the About View content. All we need to do is remove this CSS code. Now the H1 still shows up in the home route, But if we go to the About route, you won't see that anymore, and you'll also notice that the content is positioned appropriately.
Finally, that brings us to the end of the lesson. We definitely covered a lot, so if you want to grab the ending code, just check out the L3-N branch, and I'll see you in the next lesson where we cover the essentials of Vue Router. In this lesson of Real World Vue 3, we're going to look at the essentials of Vue Router. Let's get started. If you're coding along, you can check out the starting code at the L4-start branch. And if we run the project, this is what our app currently looks like. In the last lesson, we touched on how these home and about links are used to navigate between the home and about routes. And Vue Router loads up the about.vue or home.vue component depending on which one we click. And nested within that home component is the event card component we created in the last lesson, giving us all this code we're seeing here. So really what we're talking about here, which Vue Router helps us achieve, is called client-side routing. Now this differs from the older and more traditional kind of routing called server-side routing. So before we dive deeper into client-side routing, let's get a foundational understanding of server-side routing to see how client-side differs from it. With a traditional server-side routed app, a user types in a URL, the browser requests the URL from the server, and the server returns the page. If the user were to click on a link on that page, the browser would request that URL and return the new page, refreshing on every page load. On the other hand, client-side routing looks a bit different. When the user types in the URL, the browser is going to request that URL, and in this case, the server returns that page, specifically index.html, which we'll touch on in just a minute, and it sends along with it the rest of the app. And because the app already has all of the code that it needs within the browser, Vue, with the help of Vue Router, compares and then renders the differences without ever having to reload the page. We can also visualize the differences between these two kinds of routing like so. In a traditional app that is not using client-side routing, the browser is essentially going out and fetching the different content that we need from those different URLs. On the other hand, within a single-page application, like we're building in this course, we're really only looking at one page, the index.html. And as we click around it, we're adjusting which view we're seeing of that app. Hence, single page application, just that one index.html page. Remember in lesson 2, we looked at the index.html file. It's in the root directory, and on line 10 is this div with the ID of app. Remember also we looked at main.js, where our app component, which is the root component of our entire application, is being imported. And then we're creating our app and mounting it to that div with the ID of app. So again, our entire application lives at that single page, index.html. Also in this file, we're importing the router, and when we create the app, we're telling our app to use the router. So let's take a look at the router file to understand how it's all configured. Inside the router directory, it has this index.js file, and you'll notice at the bottom we're exporting router. Just above here, we're creating the router, and notice how we have this history property. We're not going to dive into history mode in this lesson, but if you want to learn more about it, check out the lesson resources below. Also here, we're passing in the routes. So let's take a look at these. As you can see, we have a routes array with 2 route objects within it. Although they look a bit differently, which I'll touch on in just a second, notice how they each have a path, which is the URL for this route, along with a name and a property to specify the component to load when we reach this route. As you can see, we're importing the home component from our views directory. Again, the views directory is where we put all those components that we want ViewRouter to be able to load up as we navigate between the different pages. In this case, we have the home and about pages, each with their own route. Now that we have a basic understanding of how the router is configured, let's look at how that site navigation is actually triggered. Notice here in the template, there are these router links along with a router view component. These are built-in components provided to us by ViewRouter. When a user clicks on this home link, they're actually clicking on this router link here, which has a to attribute specifying the path that we want to navigate to. And when we navigate to that path, because of this route object here, ViewRouter knows which component to load up. In this case, we're loading up the home component, but where do we put it? That's where the router view comes in. This functions as a placeholder that is replaced by the route's actual component. If we take another look at the router's index file, we'll notice that create router and create web history are being imported from ViewRouter. And opening up the package.json, there it is within our dependencies. Because we selected ViewRouter when we created the project with create view, that's why we're seeing it here added to the dependencies. This tells our project to use the latest version of ViewRouter compatible with this version number. Your version number may be a bit different depending on when you take this course. Now that we're starting to get a grasp of how to use ViewRouter, we're going to make some customizations to our app's routes. Our to-do list for this section includes renaming homeview.view to eventlist.view. We'll then customize the route for event list view. Then we'll update the about view file and reconfigure the about route. Because our home file is really a list of our events, let's rename this event list view. Because this file now has a new name, we'll need to import it like so. Now to configure that route object, we'll leave the path the same, update the name to event list, and specify that when we hit this route, we want to load up the event list view component. Next up, we're going to customize our about.view file. We'll change the text inside the h1 to match our app, a site for events to better the world. Now we can reconfigure the about route. Obviously, this route is configured a bit differently, so what's going on here? As the comment tells us, this is for route level code splitting. In other words, this is a performance optimization. Earlier, when I was talking about client-side routing, I mentioned how we're sent the initial page, index.html, including the rest of the app. Some of you may have noticed that there's an asterisk here, because there are situations like this where we're doing route level code splitting, lazy loading components, so we're not actually sending over the entire application code on the first load of the app. If your app is quite large, it might actually not make much sense from a performance standpoint to send your user all of your application code, every page, every view, even though they might not need it or might not need it yet. Having said all that, our example app is very small. We only have 2 routes and we'll add a 3rd later on. So we don't have to implement any of this performance optimization. So let's delete out this component and exchange this method for the name of the component that we're loading. Now we have a linting error telling us about is not defined because we need to import it. So we'll import about view from the views directory. And now our app's routes are configured. We just have one little step left. If we head into app.view, we'll just change the inner HTML here to events to better match what we're displaying in this view. Checking this all out in the browser, our routing is working exactly like we wanted it to. Awesome. This lesson just scratches the surface of what you can do with ViewRouter. We will be touching on ViewRouter a bit more throughout this course, but if you want to dive deeper, you're going to want to check out our Touring ViewRouter course, which covers all of these topics and more. Finally, to grab the ending code, check out the L4-N branch. In this lesson of Real World Vue, In this lesson of Real World Vue3, we're going to look at making API calls with Axios. As always, you can get the starting code for this lesson by checking out the L5-start branch. As our app currently stands, we're displaying these events here, which are hard-coded within the data of our event list view component. But we don't want this data to be hard-coded within the component itself. In a real-world Vue application, we want to be fetching this external data with an API call, where we make a request to our server for the events. The server sends back a response with those events as JSON. Then we take those events and set them as our local components data that we can then display on the page. In order to achieve this behavior, we're going to need a couple things. First, we'll need a mock database to pull our events from, and we also need a tool to be making API calls with. In our case, in this course, we're going to be using Axios. The solution we'll use for our mock database is my.json server. As you can see in the website, we'll just create a JSON file on GitHub, which instantly creates a fake server for us. You'll notice the instructions are very simple. First, we're going to create a repo on GitHub. Within that repo, we'll create a db.json file. That's our mock database. And then when we visit this my.json server URL, which includes our GitHub username and repo, we'll be able to access that new server. If you've been coding along with our example apps repo, you may have noticed that I've already created this db.json file. It lives under this username, CodePop, and the repo name, Real World Vue3. Inside the db.json file, we have this events array, including 3 event objects. These should look very similar to the hard-coded events within our event list component. This is the event data we're going to be fetching soon with our API call. Before we take a look at our mock server, I do want to bring your attention to the fact that my.json server is in beta and does have limits, so you may want to familiarize yourself with the documentation here to understand what you might hit up against. If we go to our my.json server URL, we'll see our server here, which includes these events that we can click on. Since this is the exact data we want to be pulling, this URL here is what we'll be using for our API call. Now that we've created our mock database and know what URL to point to fetch those events, we can install Axios. I'm going to do so from the terminal. At this point, if you're not familiar with Axios, you may be wondering why we chose to use it. It comes with a lot of different features. This is a very popular JavaScript library for achieving API calls. With it, we can make GET, POST, PUT, and DELETE requests, add authentication to our requests, set timeouts on them if they take too long, configure defaults for our requests, intercept requests, handle errors and cancel them, and properly serialize and deserialize requests and responses. So now that I've read that bullet list off to you, we can move on to actually using Axios. Like I've said, we're going to use Axios to fetch our events from our mock database, and then we'll look at refactoring things into a more modular service layer. So to implement this, we'll head into our views and open up the event list view component. We'll delete out these hard-coded events within the data and replace it with null. And go ahead and import Axios from where we've recently installed it. Now, in order to trigger that API call, we're going to use a view component lifecycle hook, specifically the unmounted hook. As the name suggests, a component has a lifecycle with different hooks or methods that are called during that lifecycle. For example, before it's mounted, when it's mounted, and so on. To make our API call, we're focused on this unmounted hook here. In other words, when our component is mounted, we want to be calling out to our server for those events. So back in the code, we'll say Axios, and you'll see we have all of these method options. We're going to make a GET request, which takes in a string URL as the argument. So here is where we'll place the my.json server link in order to fetch those events. It's important to note here that Axios is promise-based and asynchronous. In other words, if we need to be doing something with a response we get back from this Axios GET request, we need to make sure that we're waiting for that response to resolve. To achieve that, we'll add a .then here. And inside, we'll put a callback to execute when the promise is resolved. So we'll wait for the GET request to finish, and then we'll take the response. And for now, we will just log it to the console. And in case any error happens during our call, we want to make sure to grab that error using .catch and include a callback to execute when the promise is rejected, and simply take the error and console log it for now. Now, if everything is working correctly, we should see these events logged to the console. And here they are, an array of 3 event objects that we received from our mock database. Now that we're sure that we're getting this data back from the server, we can set that data equal to our local component's events data. Now, checking this out in the browser, when our event list component is created, it makes a call out for those external events, which it receives and then displays. Awesome. We're making great progress, but there's a problem with our code. As things currently stand, we're importing Axios into the event list component, but in the next lesson, we're going to add another component called event details, and that component will also need to make an API call using Axios. So if we're importing Axios into each of the components that need to make an API call, that becomes a bit problematic because each component has created a new instance of Axios. This leaves us with API code woven throughout our application, and things can get a bit messy and hard to debug. In order to clear things up, it would be simpler and more organized if we had a dedicated location within our app that handled this API behavior, such as an event service file. So let's refactor things to make that happen. In the src directory, we'll create a new services folder. Inside here, we'll create a new file called eventservice.js. And in here, we'll import Axios. Next, I'm going to paste a block of code here. So what does all this mean? At the top, we're creating our API client constant. This is the single Axios instance that we can use for our entire app. And then we've got this base URL property. As it sounds, this is the base URL for all of our calls to use. Below that, we can add some authentication and configuration for communicating with our server. Now that we've got that set up, we're going to export a method called getEvents. It's going to return the Axios API client that we just created, which makes a GET request, and we'll pass in this string /events. This is added onto the base URL so we can grab all those events from our database. Now we're ready to refactor our event list view component. We no longer need to import Axios. Instead, we'll import our event service from our new services folder. And within the created hook, we'll switch out this code for event service, then the name of that new method, getEvents. And the rest of the code here will remain the same. Now let's double check this is working within the browser. And there they are. Our events are still being pulled in, but now in a more modular and scalable way with that event service layer. That brings us to the end of the lesson. If you want to grab the ending code, check out the L5-N branch. And I'll see you in the next lesson, where we're going to create a new component to display the details of a given event, which is going to require some dynamic routing and another API call. In this lesson, we're going to continue building out our app and use some dynamic routing. As always, you can grab the starting code at branch L6-start. Where we left off with the last lesson, this is how our app currently looks. When we hover over one of these event cards, it becomes a bit larger, which makes it seem clickable. And that's the behavior we're going to implement in this lesson, where we click on an event card and we open up a view with the details of that event, which means we'll need a new component to display those event details, which we will soon create. The event details will look something like this, displaying the title, time, date, location, and description for that event. We're going to tackle this lesson in 2 parts. In part 1, we're going to get this functionality to work. When a user clicks on one of the event cards, they'll be routed to the new event details component. When that component is mounted, it'll make an API call, fetching the data for just the event that we clicked on. We'll do that by fetching it by its ID. And once we receive the JSON response for that event, we'll set it as our local component's event data, which it can then display. So our to-do list for the first section includes the following tasks. We'll first create the event details component, then add a new API call to fetch a single event by its ID, And because we'll need a way to route to that new event details component, we're going to add it to our routes and then make all of our event cards that we're displaying in the list on our homepage clickable so that they can route to the new event details component. So we'll start off creating that new component. We'll add that .vue file into our views directory. I'll paste some code here in the template so that we can display the event's details.
That event object will live in our component script. We need an event ref, so let's first import ref from Vue and initialize the ref as null. Next, we'll use the onMounted hook.
And when this component is mounted, we're going to fetch that event by its ID and set our local data equal to it. Before we add that new API call where we fetch that single event, I want to bring us back to our mock database. Remember, we're using my JSON server. And if we click on the events here, we can see all of the events that we have. In the last lesson, we needed to request all of these events because we're displaying all of them on our homepage in those event cards. But like I've been saying, in this lesson, we're just requesting a single event, and we can do so by targeting its ID. So if I append 123, that ID onto the end of this URL will fetch just this single event. So now that we're refreshed on how our my.json server is working, we can add that new API call. We'll head into our services directory and open up the event service file. I'm going to copy the get events call because the get event call is very similar. We'll delete the S, add in an ID as a parameter, and then we'll append that ID to the end of this URL. Now that our API call is written, we can start to use it.
It's going to look a lot like our implementation in the event list component, so we'll copy this code and paste it into the onMounted hook here.
Of course, we're getting this red underline under event service because we haven't imported it yet, so let's do that now. And we're no longer getting events, we're getting the event and passing in the ID of the specific event we want to retrieve. For now, I'm just going to hard code the ID here in our components data. That's not the ultimate solution we're going to end up with in this lesson, but for right now, it fits our needs.
Since ID is a ref object, we need to use the value property to read the ID. Then I'll just delete the S because we're setting the value of this event ref, not the events from the other component.
Great, now that component is ready to use, so let's add it to our routes. So let's open up the index file of our router. We'll import our new event details component and add a route object for it. For the path, I'm just going to hard code event/123. Eventually, that 123, the ID part, is going to be dynamic. But just like we hard coded the ID in the event details component, this works for now, and we're going to change it in the second section of this lesson. Then we'll just change out the name and component to event details. So now we have our new event details route, but we need to be clicking somewhere to actually access it. Again, we're going to click on the event cards and then pull up the event details. As a refresher, if we look in app.vue, remember we're using these router links to route to the root event list and about routes respectively. So we'll copy this router link and head into our components directory and paste it into the event card so that it wraps all of our code here. Inside this to attribute, I'm going to add that hard-coded path for now, event/123. Checking this out in the browser, when we click on this event card, we're routed to the event details component, but there is a little problem here. If we pull up the console here, we see that we have an error. Cannot read property title of null. The reason we're getting this error is because event details is trying to display the title of our event, but our API call hasn't yet returned its response, so we don't have an event yet. Fortunately, this is a very quick fix. We'll just head back into the event details component and add a vif on the div here and say, if we have an event, display its details, which effectively causes the component to wait until it has an event from the API before it tries to display its details.
Now it will successfully fetch and display that component's specific details.
So with that, we've concluded section 1 of this lesson. We're now ready to move on to the second section where we make this routing dynamic. Because as we see, when we try to click on one of these other event cards, we're still pulling up the cat adoption day, and the ID at the end of this URL is still 123. Again, that's because we hard-coded that ID onto the end of this path here. We had also hard-coded it into the data of our event details component, which means that no matter which event card we click, we're always fetching just the event with the ID of 123. Of course, that's not what we want. We want to be able to click on any event card and pull up that event's details. So this portion of our route's path needs to be dynamic. We really need something like a variable or parameter on the end of this path that can be updated. And for the ultimate solution, we want to be able to feed that dynamic segment into our event details component as a prop. In order to get all this to work, this is what our to-do list entails. First, we'll add a dynamic segment to the event details route. Then we'll add the event ID to the router's parameters. Then we'll give event details access to the parameters as a prop. And then we're going to do some cleanup of our code. So first up, in order to add a dynamic segment onto our path, we'll use the colon and then say ID. You can think of this like a placeholder that gets updated with the actual event's ID. In another use case, your dynamic segment might be :user, and that's updated with a username or user ID. While we're in this file, remember we have this name property here. So on the to attribute, instead of this hard-coded path, to make things a bit simpler, let's instead bind to an object, and in that object, we'll specify the name of the route that we want to route to. In this case, event details. I'm showing you this because not only is it simpler just to route to the name of the component and not have to worry about the dynamic segment within the path here in the to attribute, but also this is a more scalable solution. Imagine if your app had these hard-coded paths in all these different router links throughout your components, and then that path needed to change. You would have to go into every single router link, update that path, make sure you didn't mess anything up, and that just becomes a bit messy and hard to maintain. However, if you had just used these names here like we just did, all you'd have to do is change the path in the router file itself, and then all those names still point to the now updated path. At this point, you might be wondering, okay, so we have the dynamic segment on the path, and it's basically a placeholder that gets updated with the event's ID, but how do we actually give it the ID? Well, we can do that by adding the params property here and setting ID equal to event.id. Remember from a few lessons ago, we have access to all the event details already here because of this prop. So now when the user clicks on the event card, they are routed to the event details, and also that event's ID is added to the dynamic segment, that parameter on the URL. If we wanted to, we could access that ID parameter by using the useRoute composable in our component, which returns a route object that contains the ID parameter, and that would display something like this. Or to get more specific about our use case, when we're making the getEvent call, we can pass in the ID provided by the route parameters, effectively passing in the value of that dynamic segment. The drawback, however, of accessing the route like this is it creates a very tight coupling between the route and the component that that route loads. It's more ideal, like I mentioned earlier, to be giving the component access to that dynamic segment as a prop. And we can do that very simply. We'll just head back into our router's index file, and on the event details route, we'll say props true. So now we can send in the route params as a prop, meaning we can delete out that hard-coded ID that's in the data here, and now add that ID as a prop, which is then fed into the getEvent API call. Now let's go ahead and check this out in the browser. When we click on an event card, it looks like it's working. We're displaying the correct details of the event, and now that dynamic segment is being updated with the right ID. And while we're cleaning up our code here, you probably noticed those event cards look pretty ugly since we wrapped them with the router links, so we'll add a new class to fix that. We'll add the event link class, then scroll down to the styles, and paste in these rules where we change the color and remove the text decoration. Now they're looking a lot better. We can click on each of them and see the correct event details. For the sake of being consistent throughout our code, we can head into app.view and change what we're doing here in the to attribute. Instead of routing to a hard-coded path, we'll use the names of the routes instead. And that does it for this lesson. If you want to continue learning about ViewRouter's parameters or other ViewRouter related topics, we do cover more in depth in our Touring ViewRouter course. Otherwise, I'll see you in the next lesson where we learn how to deploy our app using Render. To grab this lesson's ending code, you can check out the L6-N branch. At this point, our example app has all the features we need it to for this course. So now it's time to build our code and deploy it into the real world using a convenient platform called Render. As a reminder, throughout this course, we've been building a single-page application, and the single page of our app is index.html. Earlier in the course, we looked inside this index.html file. We learned how our entire app is being mounted here in this div with the ID of app. For production, this file is where the build files will get injected into. Earlier in the course, we looked at how our app is created and mounted to the div with the ID of app, meaning all of our application code lives in the index.html file, where the build files will be auto-injected. So what happens when we actually build our app? If we peek into the package.json, we see that we have these scripts that we can run. Previously, we ran the command to spin up the project in a local development server. And below that is this build command. So let's run this in the terminal and see what happens. We'll say npm run build, and as we see, it's being built for production. And when it's done, we have a new dist directory. Inside the assets folder, we can see a production-ready CSS file. Another file for all the bundled JavaScript code. And below that, we have our index.html. We can see that those build files were indeed auto-injected. So now that we've seen what happens when we manually build our app, what are the other steps and considerations for deployment? There's actually quite a few things to consider. In order to deploy, you'll need to find a web hosting service, get SSL for a secure domain, build a site locally, drop those files into a server, and ensure it's being served correctly. Once your app is deployed into production, then you're going to have to maintain it, adding new features to it, fixing bugs, etc. You'll also want the ability to quickly do a rollback to a previous version in case of emergencies where you've deployed faulty code. All of this adds up to be quite the burden, and if you're not confident doing this yourself, it can be a high-stakes risk. Fortunately, there's platforms that handle the heavy lifting of deployment and redeployment for us. Which brings me to our solution of choice, Render. Looking at their website, we can see that Render is a robust and streamlined solution for our needs. We select the service type we're going to use, which allows us to deploy in seconds and enables automatic updates. So when we push changes to the repo, our app will get redeployed automatically. And it provides this collection of service options all conveniently in one place. In order to deploy our project with Render, all we need is a free account. So let's get started. I'm going to create a free account using GitHub. We'll go ahead and give Render permission and hit Authorize. Once we're redirected back to Render, we'll finish signing up. And if we check our email, we should have a verification link. When we click on that link, we'll be routed to our Render dashboard. Now that we're in, we're going to click on this New button and notice how we can create a static site. That's how we're going to be deploying our project. With Render, static sites are automatically served over a global CDN, and adding a custom domain name and SSL security comes free. So we'll go ahead and click this option. You'll notice that it's telling us that we have no connected repositories, and we can connect via GitHub or GitLab. I'll do so through GitHub. I'm already logged into GitHub, but if you're not, you're going to have to log in and then select where you want to install Render. Once I select it, you'll see I can give Render access to all repositories or select a repo. I'm going to select the repo for this course, Real World Vue3, and then hit Install. We're then redirected back to Render, where we should see our repo now connected here. We'll click on it, then run through the steps of static site deployment. You'll notice that automatically it was able to tell that we're using Vue, so some fields were auto-filled accordingly. We'll start off by giving our site a name. I'll call it Real World Vue3. And then we'll select the repo branch that we want to be deploying. In most cases, you're going to be deploying from the master branch, but in our case, since we've been building this application incrementally with the ending state of the code in every branch of every given lesson, we're going to click on L6 end, since that includes the final code for our example application. We'll leave the build command the same. And notice the publish directory here is dist. That should look familiar from earlier in the lesson. There's also some advanced options. We could add an environment variable or a secret file. And at the bottom here, by default, we have auto deployment turned on with yes. This way, whenever we do a git push to our branch, Render is going to automatically redeploy those changes. Of course, you can turn this off by selecting no if you want to handle all of your redeployments manually. We're going to leave it turned on and hit Create Static Site. Now you can see that Render is building and deploying our site. Now we can view our site live by clicking on this link. And here's our app, live out in the real world for users to visit. If we click on one of these cards here, we'll see the event details, so it does look like our routing is working, but that is actually an illusion, because look what happens when we open a new tab and I paste that same URL here. We'll see not found, and if we pop open the developer console, we'll notice we have a 404 error. So why exactly is this happening? Earlier in the course, we looked at the differences between server-side routing and client-side routing. With server-side routing, if the user goes to a URL that ends in something like about, the server is going to return the about.html file, which is then displayed in the browser. However, with our single-page Vue application, we're doing client-side routing with Vue Router. Specifically, we had turned on the history mode, which gave us this code automatically, where we're using the browser's history.pushState API to enable URL navigation without having to reload the page. History mode with Vue Router's client-side routing looks like this. If we were to go to a URL that ends in something like about, the server is actually going to return the single page of our application, the index.html, and then Vue3 is going to load the About View onto the page. While the development server was configured for us to handle this kind of behavior, a normal server is not going to be automatically configured like this. We're going to have to change things to make this happen. Fortunately, with Render, that is a very quick solution. If we head into the Redirects and Rewrites tab, we'll notice that we can add a redirect or rewrite rule to modify requests to our site without writing code. So we'll add a rule now to adjust things to enable history mode. For the source here, we're going to add a catch-all and set the destination to index.html and the action to rewrite. Now our server is configured in a way where even if we went to the about route or a specific event in our app, we're going to be served up index.html and then Vue3 takes it from there. Let's double check that that solved our issue. If we refresh, there's the event details, so it looks like it's working. To double check, we'll add another event ID. And sure enough, we're pulling up that event as well. While this has pretty much solved our issue, there is a caveat, because watch what happens when I type in a URL that just doesn't exist in our app, like /team. You'll notice in the console we have this Vue3 warning, no match found for location with path team. Let's take a look at the Vue3 documentation page to understand this caveat. Because of the fact that we just added that catch-all solution within Render, that means that your server will no longer report 404 errors because now all not found paths are going to serve up your index.html file. As you can see in the code block here, the solution is to add a catch-all route within your app to show a not found component as your 404 page. Now that we understand how to solve things in relation to history mode and that caveat, let's head back into Render and see what else they have to offer. We already looked at the Redirects and Rewrites tab, and there's other tabs that are just as useful, such as the Events tab, which shows a history of deploys that have been made. This is where we could perform a rollback to a previous build if necessary. In the Environment tab, we can set variables and secret files, and even add linked environment groups. There's also a tab to use HTTP headers, and there's also a pull request tab where you can enable pull request previews, and Render will automatically create a new instance of your service anytime a pull request is created on this branch. You can also share the site with other Render users, look at metrics, and within settings, that's where you change any of these fields that we looked at before. And also down here is where we would set our custom domain. For example, in our case, we might have a domain name called Real World Vue, and we could use that here. If you ever want to do a manual deployment, you do so with this button. You also have the ability to create a team and work together collaboratively. Speaking of collaboration, they also have this community link which takes us to their forum. If you run into any issues while taking this tutorial, you can seek help here. So we've seen how simple it is to use Render to deploy our site. And another reason why this is our solution of choice is because it can scale with you as your needs grow. It can scale horizontally, meaning you can add on additional services and additional instances of services you're already using. Or it can scale with you vertically, allowing you to add additional CPU or RAM to an instance of the services you're using. And you have the freedom to choose from a bunch of different environments. So now that we've finished coding up our app and deploying it out into the wild, where do we go from here? There's plenty more features we could add and concepts to unpack to take this app to the next level. In the next lesson, we're going to look at the different ways we could scale up our application. We've reached the final lesson of this course, and I want to congratulate you for following along until the end. We've built a simple yet solid Vue app and deployed it out into the world. So where do we go from here? What other skills should a Vue developer master? There are plenty of different features we could add to our app and concepts we could uncover within the Vue.js framework and its ecosystem of tools. And in this lesson, I'm going to give a tour of the potential next steps we could take to scale up our app in different directions. This will simultaneously provide some guidance around how to continue your Vue learning journey and how to best utilize the Vue Mastery platform to level up your skills. If you take a look at our courses page, you probably already have noticed we have our courses arranged in different categories. The ideal next course for you ultimately depends on your pressing needs and interests. So let's explore some of the main Vue concepts that come after this course and how a number of our other courses addresses them. If we continued building out our Events for Good app beyond where we left off in this course, we need a production-ready form that enables users to create new events. Forms can be one of the most important pieces of our app because they allow us to intake important information from our users. A well-done form or a poorly done form can ultimately affect a company's bottom line in significant ways. When building forms with Vue, you don't want to just build a specific form that serves one singular purpose. You'll want to know how to build a set of base form components that are highly reusable, so they can be used in a modular way throughout any of your Vue apps. From inputs to checkboxes and radio buttons, our Vue3 Forms course walks through the best practices as you build a set of form components you can use in any of your future projects. If we implemented a form where users could create new events, we'd want a nice global place to store those new events, or any global data our Vue app needed. As our app's component tree grows, it becomes increasingly harder to manage the data within our app as it's created, updated, and displayed. This brings us to Pinia, Vue's official state management library. As a Vue app grows and you have more and more views and components within those views, you're going to need a reliable and predictable way to manage how that data is stored, sent around, and updated within your app. Notice how the stores folder was installed to our project by the CLI. Let's take a look inside this sample store generated for us. The Pinia store allows us to keep track of the state of things in our app and update that state in a way that is predictable, organized, and modular. Our Pinia Fundamentals course walks you through how to effectively use this state management library so things don't get messy as you scale up your app's data needs. While we cover the essentials of Vue Router in this course, I've mentioned how there's many more navigation-based abilities available to us in this handy routing library, and our Touring Vue Router course covers many of them. So if your app needs features like pagination, guards on certain routes that limit user access, or if you need to enable programmatic navigation or nested routes, this course takes you beyond the essentials and tours various features within this routing toolset. If you take the course as outlined so far, you will have broadened and reinforced your knowledge of production-level Vue practices. Once you've completed the beginner's path, you'll then be ready for our intermediate courses. These cover everything from strengthening your Vue apps with unit testing, to adding user authentication, and integrating with popular libraries within the Vue ecosystem, such as Nuxt.js and Vuetify. And with that, I hope you feel clear on what your next steps are on your path to Vue Mastery. I wish you well as you level up your skills and expand the opportunities that become available to you as you become more skilled with this powerful JavaScript framework. I'll see you in another course. We've reached the final lesson of this